using the vectors, we can actually find many interesting things. Here is an example. If you have a plane and its equation is ax by plus cz is equal to d, this is the equation of the plane. And if you have another point, it's either on the plane or not, you have a point P over here, then you can find the distance from P to the plane using this formula. If you look at it, what you need to do is just plug in the coordinates of P into the equation of the plane and move D to the left-hand side, and then divide it by the length of the normal vector. Remember, this n over here is the normal vector, right? A, B, C is the normal vector of the plane. And we're going to explain where this formula is from, and to use it is very easy. If you can remember it, that's very good. If you can't, try to remember the principle, how we got this formula. Okay, so this is the situation we have. We have a plane over here, and assuming that we know that it has a normal direction n over here, and which is A, B, C. Okay, and we have another point. Let's say this point over here is P over here. Okay, and we want to find its distance, and from this P point over here, and we can see that we can actually drop a line to the plane and find out the intersecting point, and then we are finding this distance d over here. Okay, and because we know that the shortest distance over here will be on the line perpendicular to the plane, so we know this point x naught, y naught, z naught, and then this point over here, this vector and this vector will have the same direction. Okay, so how can we find this distance over here? And here is the interesting thing. We pick another point over here. This point is going to be arbitrary, x1, y1, z1. Okay, and then we actually connect these 2 points together, and we form a vector. So this one over here is the vector over here. Okay, so we look at this vector over here. Let's call this vector B. This vector is going to be x naught minus x1, y naught minus y1, and z naught minus z1. You may wonder why we need this vector B over here. We're going to use a projection. We say the distance d over here is the projection, the length of the projection of B onto n. Its length. Find the length of this projection. Okay, we find its length. Okay, find its length, and then we know how to do it. This in the textbook is called component of B vector in the direction of n. In fact, using a little bit on geometry, we can easily see if we call this angle theta, then we know the following thing. This d is exactly the B length and times cosine theta. And we know what is cosine theta. Cosine theta is the dot product of B and n. So this one over here, this is simply going to be the dot product of B and n over here. Okay, and because we are assuming distance is positive, so we can take the absolute value. It doesn't really matter. And then divided by the length of B and n. And we see that this part can cancel, so we end up with the distance formula d is equal to simply the dot product of this B vector and n, this direction vector of the normal vector of the plane, and divided by the normal vector's length. And if you look at it, we already have the denominator, because this denominator over here is exactly the normal vector's length. So now we just need to look at what the numerator we have. So B vector, we have x naught, x1, and y naught, and y1, and we have z naught minus z1. So dot product A, B, C, right? And then this is what we have. So we have A x naught minus x1, and plus B y naught minus y1, and plus C z naught minus z1. Remember x1, y1, z1, they're arbitrary on the plane. So we actually group them according to these points. So we have ax naught plus by naught plus cz naught, and minus you have ax1 plus bx1, by1, and plus cz1. So this is what we have. Now, if you look at this second one over here, since x1, y1, z1 is on plane, on the plane. So what you see over here is that ax1 plus by1 plus cz1 should satisfy the equation, so it's going to be d. So that's how we got that numerator over there. So we have the d is equal to ax naught plus by naught plus cz naught, and this part over here is replaced simply by d and divided by the length of the normal vector, and that's what we have, the formula. And you can easily find an example in the book to practice over this formula. All right, that's it.